Hello, everybody, and welcome to the second day of PyCon Sweden 2021. And this is the software track. Uh, I have the pleasure to introduce to you Marcus Näslund, who is a software engineer who has previously worked at Klarna in Stockholm and currently is working as a teacher of IT. He is passionate about programming, technology, education, and mathematics, and believes in that everything in life is an optimization problem. He will present to us today a talk called Python++, Here's How and Why Not. So welcome to the stage, Marcus.
Thank you. Yeah, thank you, and thanks everyone for being here. At least I hope you're all here. I can't see anyone, but I feel you anyway.
The stage is yours.
Thank you. Right, so this is Python++. Here's how and why not. So I'm going to start off by showing you a small piece of code, and I want you to tell me what programming language this is written in. So simple enough. Ready? Here we go. So what language is this? I'll give you a few seconds to think about it. And there. So what actually was that? And those of you thinking I'm at a Python conference and therefore that was Python, you were correct. But those of you familiar with C++ may have said that, and you would also be nearly correct. And in fact, this C++ snippet is eerily similar to what we just saw. So, and this is fully functioning Python code, assuming you have these specifically crafted cout and cin and endline classes put in some std.py file or module. Of course, the comment at the top there is nonsense, and return 0 is nonsense, and the semicolons are all nonsense, but they complete the C++-ish picture. Of course, this in Python could be done a lot easier with just input and print. We all know that. So what was actually happening before? How do you make that kind of stuff work? And why wouldn't you want to make that kind of stuff work? That's kind of what this talk is going to be about. Let's come back to that very soon. Let me first just say I'm very happy to be here. I'm very happy to be back. So this is not my first PyCon visit. I gave a talk here last year as well. That was on web automation. The talk, machine learning for auto navigating websites, you can find on YouTube along with all the other great talks. So as Rasmus said, I used to work at Klarna in Stockholm, and that talk was based on my work there. And since then, I've become a full-time educator at a company called Nordlo for various college or yrkeshögskola courses in programming, including then Python. And through that, I've come to realize that we, as in the people in this in the Python community, make a big fuss about this concept of Pythonic, and we kind of do it in a way that other languages don't. I mean, say C and C++ is generally a mess, and there are a lot of conflicting ideas of what actually constitutes good style and good code. And I've worked as a C++ developer for several years as well, and I'm not knocking any of the work happening there, but it's clearly a very different world, and there's a lot of legacy code, and there's a lot of dependencies on all this stuff. And if you look at more modern languages like, say, Go and Rust and so on, that come with formatters actually built in, and have a lot of code actually based off of examples and idioms that are carefully designed for that language. Go has this neat standardized way of passing around error status and so on. But even so, no one really talks about what's Goonic code in the same way that we do here, or C++ and so on. And if you were to Google what is Pythonic, the first result is from the Udacity blog that says, Pythonic describes a coding style that leverages Python's unique features to write code that is readable and beautiful. So that's very nice. But what does it mean? And why don't we write Python like this? And in an attempt to answer that question, so what is Pythonic? Let's think about why does Python code look and feel a certain way? At least why does good Python code look and feel a certain way? Why don't we have curly braces, for example? And what is it that distinguishes Python from other languages? We can get some ideas from the very nice import this Easter egg that's been part of Python since I don't know when. For example, that there should be one, preferably only one way obvious way to do something. That flat is better than nested, or that errors should never pass silently, and so on. So this is the Sen of Python by Tim Peters. And to understand what these things mean, let's try to compare Python to another big scripting language, like, say, JavaScript, which is very different. I'm not saying it's worse. I'm also not saying it's not worse, but that's for another day. But in JavaScript, errors certainly can pass silently. There's a lot of nested code. It has a very different syntax revolving around these C-style curly braces. And all of that has a definite impact. So I want websites to render as best they can, even if there are errors. And that type of syntax that is not white space based also means that you can minify code a lot more than otherwise. And 25 years ago, when we needed a client-side web language, being able to minimize file size and bandwidth usage was life and death, and probably fundamental to why Python wasn't the choice there. Also, before we move on, I should add, if you ever want to minify Python code, of course you can. Just head on over to a website like this, and whatever beautiful code you've written before will end up looking like this. But your file sizes will definitely be smaller for some reason. And if you think this is a weird thing to do, then things are about to get a lot worse. Anyway, let's get back to what distinguishes Python as a language. So I actually had this talk. I had the idea for this talk some years ago. I wanted to talk about features from other languages and what could they look like in Python. For example, there's switch statements that we see in many languages like C or Java and C# to simplify a lot of compounded if statements. Well, except it's actually a feature now. So there's match and case, which also do a lot more than just cleaning up if statements. So this is PEP 636, part of Python 3.10 that was just released earlier this month. So let's not talk about that. But then I thought, hey, a lot of older languages like Pascal, which is where I first learned to program, has colon equals for variable assignment. So I thought it would be cool to crack open CPython and add a new assignment operator. You sure can, but that's also a feature now as of Python 3.9. So this is PEP 572. Where you can use colon equals to to variable assignment as part of another expression. So in an if statement, in a list comprehension, or as a loop condition, which is quite neat. So let's not talk about that either. And finally, curly braces. So you can even do those type of C-style curly braces in Python, and avoid the white space-based syntax. I don't know if you know, you can just do from future import braces. Nah, I'm just kidding. This is an Easter egg that just throws a syntax error. So for all intents and purposes, I think we can at least agree that that type of syntax is not Pythonic. But before we move on, of course, I should say as well, if you want to go the other way and bring Python-style white space-based syntax to other languages, of course you can, if you really want to. That is not something I recommend, but it's certainly possible to do. In any case, those were at least 3 examples showing how Python certainly has evolved quite significantly in recent years. I mean, we've seen a lot of feature additions coming in Python 3.7, 3.8, 3.9, and now 3.10. And we've seen that even though the concept of Pythonic hasn't disappeared, it has maybe evolved, it has maybe changed, but it's still there, and we still talk about this concept in the same way to describe good code. So to answer perhaps what Pythonic means, let's instead turn our attention to features that are currently not in Python. And I want to look at 3 things that Python does not have. So we're going to take a closer look at that C++ style input and output from before. I want to talk about constants. I want to talk about the concept of private methods. And let's consider why or why not these things could or could not be considered Pythonic. So first off, the C++ way of doing output with std_cout can certainly be done in Python. An example would be, actually it doesn't require that much code. So here's an example of an OStream or an output stream class where you overload the left shift operator to just pass in whatever value you want to and write that to a specific stream. And doing it this way with a class allows us to also do separate instances for cout and cerr and so on. I should say this is not my original idea. It's been done by actually many people over the years. There was quite a big discussion about this on R Python on Reddit some time back. All the posts on this typically end with apologies for whatever trauma the code may cause. So I should say that as well. But output like this is only very easy. Input is a little harder and requires a little bit more code, but is very doable as well. So in the same way, we can create a cn class. We overload the right shift operator instead, because that's how you push data to a variable. And the trick here is to be able to actually edit the original variable, which is otherwise passed by value here. And the trick is to use the inspect module to find the previous stack frame and whatever variables were in scope there, and then change the value like this. So this is a trick to avoid having to declare that variable as global and so on. And putting these 2 things together, so cout and cn, in some sort of standard.py file, finally allows us to write code like this. So exactly what we saw in the beginning. And again, the preprocessor directive include iostream is just a comment in Python, but it definitely completes the C++ picture here. Now, why wouldn't you do this if you don't think that's obvious? Then one main tenet of Python is that there should be one and preferably only one obvious way of doing things. I mean, we certainly wouldn't want several ways to do string interpolation, for example, even though there is one or two or three or well, actually four ways of doing exactly the same thing. But these things, they do have different use cases, and they definitely show how this type of stuff has evolved over time. And then the string templates are relatively unknown, but they do have some security features that format strings otherwise risk. So CN and COut classes don't add anything new and don't really show any evolution of the language. And certainly don't do anything that couldn't already be done simpler with print and input. So let's look at something more exciting. So constants. We certainly don't have those in Python, unlike many other languages. Any variable can be reassigned at any time, even a variable that you import from another module. So lately, a final type was introduced into the typing module. So you can mark a variable as final, and if you use MyPy or whatever type checker you prefer, it can alert you if you're trying to change it. But of course, you still can. You still can if you really want to. And historically, there have been several different attempts to do something constant-like in Python. For example, with name tuples or properties, or recently with frozen data classes. Another way of doing constants is this. So create a class, just call it const or underscore const in this case, and we can override setAttr to put any sort of name value pair in the internal dictionary of this instance, and we can do a little bit of Python magic as well to make sure there's only one const instance already available when you import the module. And if you're trying to assign a variable that already exists within the internal dictionary, this raises a const error. And that allows us to do something like this, where you just import const, and then you can assign a variable that is declared constant. And if you're trying to change it, for example, that raises an error. So I think this way is also kind of neat. And a cool way of doing constants. The problem is this really isn't constant, and if you really want to change the value, you you definitely can. So you could do exactly this with pi instead of magic, then, and just change whatever value you want at any time. So that's why I wouldn't call this Pythonic, as in a core feature. The recurring feature is to be able to change anything at any time, and you see that in a lot of other scripting languages. At the same time, we see that data classes can be frozen and so on. So maybe I'm just old-fashioned. I will concede that it's useful. Lastly, let's talk about access levels for class and instance members and methods, which we do have in many object-oriented language. In Python, you can prefix with an underscore to highlight this. But like constants, you can always get around that. Just call the method anyway. And most of you probably know you can prefix with a double underscore to make it really, really private. But it's not really private. It's just name mangled. And if you can figure out the new name, then you can just use that anyway. But wouldn't it be nice to be able to make something that's really private, and I thought so, and I wrote this private method decorator. So let's just take a quick look at how that works. And basically, yeah, the idea is we pull up the stack frame of the current call, again using the inspect module. So we pull up the stack frame of the current call, and we pull up the stack frame of the or the previous stack frame before that. And if this is a method called within the same instance, there should be a self argument in the previous stack frame that's identical to the self argument in the current stack frame. And if that's the case, then this is an internal call, and we can allow it and call this decorated function. And if not, we throw an access error, and this allows us to do something like this, where we have a class with a public method, and we have a class, we have also a private method that's decorated like this. And if we try to do something like this, then calling the public method is perfectly fine. Whereas calling the private method on the final line, there is no self variable in that scope, and so this throws an access error instead. So I was pretty pleased with this and thought I'd upload it, but then I discovered that someone else also had this brilliant idea. So if you really want this, you just need to get access modifiers from pip, and on you go. At least it was nice to see I wasn't the only crazy person around. But this is clean. It's maybe useful. It does go against another tenet of asking for forgiveness and not permission. But like constants, I would concede that it can be useful, even though it goes against other established conventions. So anyway, you might think that this talk was pure madness, and you'd be correct. And I do apologize. And here's a cute cat. But we have seen for the past 20 minutes that there are some features from other languages, like from things that we know from C++ and Java and C# and so on, that have made their way into Python. And we've seen some examples of how more of them theoretically could. And all languages evolve and change over time, and that's awesome. And have we answered the question of what Pythonic means? Well, maybe not, and it may not have a definitive answer. But if anything, the thought I want you to carry with you from this talk is that good quality code really matters. And good quality means embracing idioms and customs and ideas set forth and proven by other developers before you. And whether you're new developer or experienced, I do urge you to take some time to find out what exactly Pythonic means, especially in the context of wherever you work. And we've clearly seen some examples of what it doesn't mean, but maybe some ideas of what might happen with Python in the future. So with that, I do a big thanks to you for bearing with me during this talk. You can find me on LinkedIn or this address later, and I'm also available in the Slack space after this. And if we have any time now, I'm happy to answer any if there are any questions. Thank you.
Thank you so much, Marcus. So we can wait just a few seconds for any more questions, but I see there are some comments on YouTube that we could bring up. And it was quite, thank you so much for the great talk. It really makes you think. For example, the Python example that you showed in the beginning. And we have some, someone called Not Really says that he's had you as a teacher, and I think you're really good.
Thank you.
Someone thinks, Johan thinks perhaps that technology has gone too far.
Yeah.
What do you think about that?
Well, I mean, to actually treat that question seriously, I do think there are some who might say something of like there have been a lot of feature additions to Python quite quickly over the past couple of years, and I think maybe we won't see that kind of rapid expansion going forward, at least for a couple of years, because it does take a lot of time for these types of features to mature and stabilize, for example. So, but yeah, I'd say no.
Do you think we need these feature additions for Python? Is it or why? Is it because like C++ developers or similar there that have been developing in another language can feel like at home in Python, or is it just that it was needed from the start?
All right. I think if maybe it was needed from the start, but I think if anything, the idea from this talk is that that's probably the wrong way to think about it. Is that if you're used to doing something in one language, that is not necessarily at all a good way of doing it in another language. There's a reason why it's why we're using cout and cin in C++, and there's a reason why we don't need that kind of construction in Python, for example. I think it's more, we see a lot of good ideas coming around, but implemented in different ways in different languages.
And it was quite funny, actually, when you brought up this future import. Actually, you kind of fooled me. But
No,
I should have known.
Yes, I love that. I don't know how long that's been there, but it's always a good joke.
Mm. So I actually have a question. What's your opinion on type hints? Do you use them or?
Generally, yes. I think they are really powerful. I think it is. I think it's nice to be able to, I can still I avoid them, or if it's something quick that I'm trying to prototype, I can just choose not to do it. But generally, I do enjoy the sort of safety or bug avoidance that they provide. I haven't, for example, I'm not sure with, for example, the final type that I mentioned in this talk, if that's actually the right way to go about it, or if like do I want the type system to tell me if something is a constant or not, or should there be another mechanism? But in general, I think it's useful. And I remember when I was at Klarna, we had an internal survey of the people who are working with Python, how many are using MyPy and typing and so on, and pretty much everyone there was. So I think that's in general very popular, at least it's been in my experience.
Mm. And as Helio says, then well, it doesn't enforce type. So he thought it was not very useful, but perhaps it can serve as documentation at least.
Sure, but I think yeah, it does. I see there helps on tests. Yes, I think it also, you could say the same thing about any sort of static checker or linter as well. That you can certainly avoid it if you want to, but that doesn't mean that it's bad, right? It's all about writing good code. Is some level of vigilance is always required.
Hmm. And we have Andre says thank you, and John also thank you. And we have one more question here. Is there any, from Yuan, is there any features that you would like to have in Python that perhaps aren't considered Pythonic by default?
Well, that's a great question. I mean, I think the match case that suddenly made its way in just a couple of weeks ago is something that was I've seen is very powerful in several functional languages that use them quite heavily, because it's not just a normal switch case that you see in C++ and Java, but it actually does some deconstruction and variable assignment and this type of stuff. So it's actually a lot more powerful than that. So I'm actually right now I'm just very excited to try that out more and see how that works. in Python.
He follows up with maybe Go too.
Yeah. Actually, for there's some old languages, some old games written in BASIC that I would love to port to Python, but it's really hard because they rely a lot on GoTo, and I can't really translate them to Python that easily. So that is a feature to watch out for, maybe for 3.11. Yeah.
And Helios, that's great talk. And thank you very much, Marcus, for this very interesting talk. And hope to see you again next year.
Thank you. Thank you. Goodbye.
Goodbye.